So this one looks here like if I let u equal the inside function, the derivative will be there. So if I take the derivative, I get, negative 6x dx. So you're looking for this core basic x dx, and it's there, right? It's just with a number out the front. So I'm going to move the 4 on the outside. And again, I'm going to suggest that you separate things. So x dx. Okay, so I'm going to play with this. I'm going to say this is the same thing as saying negative 1/6 du is x dx. So this comes out, and negative 1/6 du goes in. So let's see what else I've got. I'm going to put this in for the u, so I put parentheses here, right? 1 over the square root of u, and then integral sign carries along, and then this number 4, try to get red 4 out in the front. So let's fix it up. So I would get a negative 4 over 6, and then I'm going to rewrite this as u to the negative 1/2 du. Now I'm ready to take the antiderivative. So that's negative 2/3, right? Just simplifying that. I get u to the 1/2 times 2 plus a c, so I get negative 4/3. And then put the x's back in to the 1/2 plus c, and we're done. All right, so it was a good choice to make u equal to the inside function because the derivative of it was hanging around. All right, you are going to see something on your memory quiz, and I'll prove it for you. But in your memory quiz sheet, it says, if you have 1 over the square root of a squared minus x squared, and you're thinking, wait a minute, isn't that really, really close to arc sine? It is. Okay, so then let me just write what the parallel is here. So the parallel would be 1 over square root of 1 minus x squared dx. You know this is arc sine of x, and then plus a c, right? This is going to be inverse sine of x over a plus a c. So this is just yet a new thing to memorize you'll have done by Monday. So you look at this and you say, oh yeah, let's pull the number 4 on the outside. Take the time to rewrite this. So it's 3 squared minus x squared dx. So can you see that the a is 3? So then the answer will be, carry the 4 along, inverse sine of x over 3 plus c. And that's the answer. Let's look at this one. So here, I'm going to let u equal the inside function. So if I let u equal 2 to the x, then du is 2 to the x ln of 2 dx. I'm going to make some room here. And so now I can take this. So let's make sure we know how this works. So 2 to the x and dx come out, and I can put in a 1 over ln of 2 du, right? 2 to the x dx comes out, and I put in the 1 over ln of 2 du. Okay, so the red for the green. And so then I'm looking at, what do I have left? I've got the cotangent, and I put the u in there. And once you're done finishing up with the section 2 notes, you now know the integral of cotangent. Oh my goodness, so much to memorize. So the integral of cotangent of x is ln of the sine of x plus c. So we just do that. We carry along the 1 over ln of 2. We get ln, the sine of u plus c, and then I finish off by putting in what the u is. So sine of 2 to the x plus c. Lots to memorize. This is my way of just getting us to practice it. Okay, so let's go on to number 4 here. So you are going to see that there's a new integral that has to do with arctangent. You already saw an integral that has to do with arc sine. I think that is it, and this is not, right? This one has the x dx. So if I pull the 4 outside and put the x dx and then root 16 minus x squared, again, take the time to rewrite it if that would help. And then times x dx. Okay, so now let's invest time in seeing what could be the inside function. I'm thinking inside the radical. Will that give me what's left over on the outside? It will. Okay, so let's do it. So if I let u equal the inside the radical, du is negative 2x dx. There it is, except for the 2, right? So negative 1/2 du is x dx. So I get negative 1/2 du, put parentheses there. And let's see, I'm going to put the u in here. So I get 1 over root u. And then I just carry this 4 along on the outside. Simplifying, these two things give me a negative 2. And I'm going to rewrite this u to the negative 1/2. And take the antiderivative, so u to the 1/2 times 2. So I get negative 4, and put the u back in, 16 minus x squared to the 1/2 plus c. Okay, so that was number 4. Number 5, let's remind ourselves, I think we know this from the new thing we've got memorized. By month, you're going to have all this memorized, right? So this is the same thing as saying the number 4 times square root of 4 squared minus x squared dx. So that fits the pattern for the arc sine. So then you get equals, so the number 4 carries along, and I get the arc sine of x over 4 plus c, and you're done. So let me just finish this last one on this page. So I see I'm going to need a u substitution for sure. How about we let u equal that inside function, u equal e to the negative 2x. So the derivative is e to the stuff times the derivative of stuff, right? So let's see what I can do here. I can just kind of move this apart in the original problem. So this is the same thing as saying tangent of e to the negative 2x times 1 over e to the 2x dx. Okay, if I go back over here and rewrite this, can you see that this is du is negative 2, 1 over e to the 2x dx. Oh, there it is. This is this, right? So if I just do a negative 1/2 du, that gives me 1 over e to the 2x dx. So I can take this out and put in a negative 1/2 du. All right, let's see what we've got going on here. So this, I carry along the integral sign, and I take the integral of tangent of u. So make sure you clean it up, right? So I'm going to pull it down here. So clean it up and say, all right, that's the same thing as saying negative 1/2 integral of tangent of u du, and yet this is another one you want to memorize. So this is ln of secant of u plus a c, and so then ln of secant of, and then the u is equal to e to the negative 2x plus c.